Welcome to our new podcast series on large language models. Over the next 30 episodes, we're going to dive deep into the world of LLMs, exploring everything from foundational concepts to cutting edge architectures.
We're so excited to kick this off. Today's episode is all about setting the stage, why LLMs matter, where they came from, and what you can expect from this series.
Let's start with the big question: what exactly is a large language model?
At its core, an LLM is a neural language model, a system that learns to model a probability distribution over sequences of tokens. In simpler terms, it predicts what comes next in a piece of text based on patterns it learned from massive amounts of data.
Think about when you're typing on your phone and it suggests the next word. LLMs work on a similar principle, but at a much larger scale with far more sophisticated understanding.
Exactly. And these models have become incredibly powerful. We're talking about systems like GPT, BERT, Claude, and many others that can write essays, answer questions, generate code, translate languages, and so much more.
So, where did all this begin? LLMs didn't just appear overnight.
Right. The story really starts with neural networks themselves. Back in the 1950s and 60s, researchers began experimenting with artificial neurons and simple perceptrons. But it took decades of research, better algorithms, and crucially, much more computing power to get where we are today.
The real breakthrough came in 2017 with a paper called Attention is All You Need from researchers at Google.
That paper introduced the transformer architecture, which fundamentally changed how we build language models. Before transformers, we relied heavily on recurrent neural networks that process text sequentially, one word at a time.
Transformer use something called self attention, which allows the model to look at all words in a sentence simultaneously and understand how they relate to each other.
This parallel processing made transformers much faster to train and better at capturing long range dependencies in text. It's the foundation of almost every major LLM today.
Now, why should we care about LLMs? What makes them so important?
Hello, my names that represent a major shift in how we interact with computers. Instead of clicking buttons or writing specific commands, we can now have natural conversations with AI systems. They understand context, nuance, and can help with complex tasks.
They're being used everywhere, from customer service chatbots to helping doctors diagnose diseases, from writing code to creating educational content.
And what's particularly exciting is that we're still in the early days. These models are getting better rapidly, and we're discovering new applications all the time.
So, what can you expect from this series?
We've organized this into 5 phases. In phase 1, we'll cover the foundations, what foundation models are, the evolution of neural networks, transformers, training basics, and transfer learning.
Phase 2 dives into the core mechanics, how tokenization works, attention mechanisms, pre training versus fine tuning, scaling laws, evaluation metrics, and the challenges developers face.
Phase 3 is all about transfer architectures, domain adaptation, parameter efficient fine tuning techniques like LoRa, instruction tuning, multilingual models, knowledge distillation, retrieval augmented generation, and multimodal approaches.
Phase 4 explores advanced architectures, including mixture of experts, test time scaling, infrastructure for training, data curation, deployment optimization, and the open source ecosystem.
And finally, phase 5 looks at the future, ethical considerations, applications beyond text, and where this technology is headed.
Throughout this series, we'll be explaining technical jargon in plain language, so don't worry if you're not an AI expert.
Our goal is to make this accessible while still being comprehensive and accurate. We want everyone from curious beginners to experienced developers to get value from these episodes.
One more thing before we wrap up. These models are built on the concept of deep learning, which means they have many layers of interconnected artificial neurons that transform input data through increasingly abstract representations.
And the large in large language models refers to both the amount of data they're trained on, often hundreds of billions or even trillions of words, and the number of parameters, which are the learned weights that determine how the model behaves.
Modern LLMs can have anywhere from billions to hundreds of billions of parameters. More parameters generally mean more capacity to learn complex patterns, though there are important trade offs we'll discuss in later episodes.
So that's our roadmap. We're going to build your understanding from the ground up, explaining not just how these systems work, but why they're designed the way they are.
Next episode, we'll tackle foundation models, what they are, what makes them different from traditional AI, and why they've become the backbone of modern AI applications.
Thanks for joining us on this journey into the world of LLMs. If you're excited about this series, make sure to subscribe and follow along.
Until next time, keep exploring and stay curious about